Hello and welcome viewers. Welcome to your session that we shall continue our topic on the probability distribution. Just we were discussing about the binomial probability distribution. Then in the same case we see few more examples. Say let us consider a student is given a true-false exam with 8 questions. He must get at least 6 correct answers to pass the exam. But given the student guesses the answer, what is the probability that he will pass the exam? Now we see there are some important points in the problem. It is a true-false problem. True-false problem, same as we toss a coin, head and tail. Either the student has to take true or the false. With 8 questions, it means there are the total number of the trials. The student can attempt 1, 2, 3, 4, 5, 6, 7, 8 or no questions. He must get at least 6 correct answers. It means in this portion, the random variable is fixed for a particular or a specific value. So we use the binomial distribution in this case. Let us say, let x denote binomial random variable, that is student pass the exam. The probability of success, the success P is equal to 1 by 2 and Q is equal to 1 minus P, that is again equal to 1 by 2. Because there are only 2 options, true or false. If in place of the true false, if we would have taken the 4 options, the success was 1 by 4. And Q is equal to 1 minus P, that is equal to 1 by 2. And total number of trials, they are 8. The 8 questions are in the exam, so the total number of the trials are 8. We use the formula for the probability distribution in binomial, that is NCX into P raised to the power X into Q raised to the power N minus X. Here the probability is that student will pass the exam. He will pass the exam if X is greater than or equal to 6. It means when he gets at least 6 correct answers. It means when P is equal to X is equal to 6 or 7 or 8. That's addition theorem. P X is equal to 6 plus P X is equal to 7 plus P X is equal to 8. Since all the values, they are independent of each other or they are mutually exclusive, then for this, that is 8 C6 into 1 by 2 raised to the power 6 into 1 by 2 raised to the power 8 minus 6 plus 8c7 1 by 2 raised to the power 7 into 1 by 2 raised to the power 8 minus 7 plus 8c8 into 1 by 2 raised to the power 8 minus 8 into q raised to the power 8 minus 8. That is equal to 8c6 into 1 by 2 raised to the power 8 plus 8c7 into 1 by 2 raised to the power 8 plus 8c8 into 1 by 2 raised to the power 8. Here 1 upon 2 raised to the power 8 we take common, that's 8c6 plus 8c7 plus 8c8. That's come to be equal to 2 raised to the power 8, that is equal to 1 upon 256 1 upon 256. If we expand this combination we get 28 plus 8 plus 1, and that is equal to 37 divided by 256. That is a problem based on the binomial distribution, and in this problem we have seen how do we select the type of the probability distribution for a particular problem. Now let us see some more numericals in spite of the problem based upon the mean and the variance of the binomial distribution that are different from the random variable. For the binomial distribution, we say mean is equal to n into p, and standard deviation is equal to n into p into q. With the help of this we can solve many problems like this. Say the mean and standard deviation of a binomial distribution are 20 and 4. Find all the parameters n, p and q. Simple, we can use the above results. We are provided with the mean. Here mean is equal to n into p, take it number 1, and standard deviation, that is equal to under root npq. Standard deviation is under root npq, take it number 2. Squaring both sides of 2 we get variance. The npq, this implies here mean is 20 is equal to n into p, and this implies standard deviation is 4 is equal to under root npq. It's number 1, it's number 2. Or this implies 16 is equal to npq. It's number 3. We scaling both sides. This function will divide 3 by 2. 16 divided by 20 is equal to npq divided by np. np cancels. We get p is equal to 4 upon 5. From 1 we can get from 1 20 is equal to n into 4 upon 5. Therefore n is equal to 20 into 5 divided by 4, that is equal to 25. And q is equal to 1 minus p, that is equal to 1 minus 4 by 5, that is equal to 1 by 5. In this manner, in the simple way, we can solve the numerical problems based on the mean and the variance of a binomial distribution. Now,